Hello everyone, welcome to our 28th meetup, Emerging AI Trends to Watch in 2021. My name is Dovydas, and let me introduce myself really quickly. So first of all, if you want to connect with me, the best way to do is via LinkedIn. I use that for all my professional contacts. What do I do? First of all, I'm the president of the Artificial Intelligence Association of Lithuania. I'm also a team lead, machine learning team lead at Vinted. I'm the founder of Tribe of AI, and I'm also a data science lead at Turing College. So if you want to talk about anything that I do, by the way, it's all about artificial intelligence and machine learning. But if you want to talk about these things, reach out to me on LinkedIn. So let me tell you about our plan for today. So first of all, we have quite a few community updates. They're really interesting, and today I guess the main spotlight goes to the community updates. Then we'll have the presentation Emerging AI Trends to Watch in 2021. Finally, we have some networking and Q&A part. So if throughout today's presentation you have a question, or you want to raise a topic for discussion at the end, or I don't know, you just have a comment, so visit on the top of the screen you'll see the Slides app Google with the hash. So visit this URL and you should be able to ask questions. By the way, don't ask your questions on YouTube. There is a delay, and it's much easier for me if you ask for questions right here. So that said, let's dive right into it. Community updates. So first of all, one really major achievement, that it's not only our 28th meetup, it's also the 4th joint meetup by Artificial Intelligence Association of Lithuania and Tribe of AI. So really happy that the two organizations joined forces, and now we have consistent and regular meetups which share update for the AI community in Lithuania. In addition to that, one really major achievement, that is we finally have the Lithuanian version of our website. So let me show you that real quick. So here, if you go to lithuania.ai, now you see you have two versions. You can choose English or Lithuanian version, and I'm really proud of the board members of the association who worked hard to make this version come to life. And as always, you see the very good regular stuff, the same things which you would see in the English version. So now everything is translated, and you can have the Lithuanian version. So let's get back. One more important update is that finally our members page is live as well. So let me show you that. Oh, sorry about that. It's the wrong one. So the members page is live. Again, we put some work into that, and finally we have, maybe I'll zoom in a little bit. Finally, we have the list of all members of the association. So this is actually actionable. So let's say you are interested in somebody who knows deep learning. So you can search by keywords, and these people have deep learning as their interests. Maybe you are interested in computer vision, so you can search for people who are interested, or who say that their interests are computer vision. Maybe you're looking for somebody to speak at one of your events about artificial intelligence, so you have public speaking listed for all of these members. So by the way, if you want to go into more details about each of the member, you can just go ahead and let's take Jogundas from Occipit as an example. So Jogundas he's a board member. This is his LinkedIn. You can visit, like connect to him via LinkedIn. His interests are AI in Lithuania, machine learning, and data science. I guess, I guess we can expand that to be computer vision as well. If you take, maybe we can take Mindaugas Bružas. He's a member. His interests are like computer speech, also starting startups, artificial intelligence project management, biohacking, and deep learning. So as you see, we have interests and the total list of all the members here. And like what's also really cool is with this flexibility to quickly go ahead and search for whatever you are interested in. If you don't like, if for some reason you need a more detailed version, if you don't want to click for like on all the members to find out their interests or whatever their LinkedIns, you can just switch to the detailed information view. And inside the detailed information view, you'll immediately see names, like joining dates, LinkedIn's, images, and interests in one page. Again, you can use the search right here. So maybe you are interested in people who can do research together with you. Research. Yep. So these people have indicated that their interests are research, or maybe you can just want to find all the board members. So this is like this search can also help you to find all the board members. In addition to that, we have added, not yet finished by the way, as you see, we still have like a few missing photos, a few missed LinkedIns, some like joining dates are not there yet, but it's like 95% usable, so go ahead, use it. The same goes for our like corporate partners, so these companies are also members of the association, but as companies, so they support the association even more. That they have more resources, so therefore they get like a more like promotions from like as companies rather than just individual members. So we are really proud to present you this new and updated members page. And if you want to join our association, you can go ahead and do that. And by the way, if you visit, let's use the Lithuanian version today. So you just click to join, then you can read the association's bylaws. You can fill this form. By the way, this form is not super complicated, but we really need you to answer all of these questions like thoroughly. So we need to know, are you a company or individual or a startup? And finally, please like explicitly write what are you like, what's your motivation for joining the association, and how are you or your company related to artificial intelligence? Like what do you do? Do you do research? Do you do like do you have a product based on artificial intelligence? Maybe you're just learning, that's also fine, but we really only accept members who are active in the artificial intelligence community, or I guess who are like really working with in the artificial intelligence field. So if you want to join, you're very, very welcome. We want to keep expanding our member base. As you see, we don't have like too many members yet. As I mentioned, we are quite selective. So all of these people are like really well versed in like some part of AI, and or their companies do a lot with AI. So like it's a pretty selective group, but we are looking to expand and have like a bit more members in the future. So it's an excellent time to join right now. Let's get back to the presentation. So you can become a member. Just go ahead, fill the form. If you are active in AI, we are very happy to have you. So that's all for the Artificial Intelligence Association. Let's talk about Tribe of AI updates. I mentioned that during the previous meetup. We are still looking for mentors for the AI Academy. And if you have experience and you would like to help the next generation of machine learning or deep learning engineers or data scientists, so please fill this another form, and you will be able to hopefully if you are selected, you will be able to help the next team of learners learn machine learning, learn data science, and progress through this AI Academy path. Let's continue. I guess it's not really interesting to be a mentor if you don't have a team. So one really big thing happening in Tribe of AI is a few new teams. We are forming a few new teams, and I think in really maybe 9 months or something, we are finally starting new beginner group. So we are starting class F, and so if you are just a beginner, it's really a unique opportunity to join the AI Academy right now. By the way, I don't have a lot of information right now, but everything will be posted on Tribe of AI, and maybe in about middle of January, we are going to start this new form, like this registrations for the new forming team, and hopefully they'll start in the second or the third week of February. So that's all for the updates, the community updates. I'm again, as you can see, really excited about all these the new teams for AI Academy. Turing College just started their second batch of students. Artificial Intelligence Association is growing their member base, and also doing these improvements to serve and represent the AI community in Lithuania. So I'm really happy in what we achieved so far in the year 2020. But let's talk about the next year. Let's talk about the emerging AI trends in year 2021. So by the way, when you think about it, year 2020 was quite dividing. There were some bad things, and I guess the virus is the key bad thing which really made this year unique. At least that's from my perspective. But in addition to that, we had this pretty amazing stuff. One of these really amazing things were GPT-3, and I really liked this tweet from Sam Altman. By the way, for those of you who don't know who he is, Sam Altman is the CEO of OpenAI, and the OpenAI, the company which developed GPT-3, and he was really like his tone here and his humility, because everybody at that point in time, people were losing their minds over GPT-3. They were like, oh, so is it AGI? Is it the first step to AGI? And they're I mean, it was pretty exciting time, and people were super prone to hypes. I guess that's the thing which I learned at that time, that people were like, okay, so maybe this is real intelligence. So GPT-3 is not real AGI, it's not even close. And this is what Sam Altman says. It still has serious weaknesses, it still makes very silly mistakes, but it's a very, very nice first step. So what I really like is that like this kind of humility, but at the same time he's very clear that AI is going to change the world, and GPT-3 is not the thing which is going to do that, but that's the first step in the right direction. And I guess that at that time, like a lot of us have thought about, you know, so maybe like why is he saying, why is this thing not AGI? And Gary Marcus, another great person in AI community, he really likes this ladder to the moon type of thingy. He said that about deep learning. Now he's saying the same thing about AGI. I really dig that, especially for GPT-3. It's a ladder which will not get us to the moon, and but you know, it's a first step. It shows us that you know, we are making progress, and it's so nice to see progress. It's so nice to see progress being made. Maybe not directly to AGI, but you know, nobody ever claimed that GPT-3 aimed to be AGI, or it was a stepping stone to AGI. So what I think like what's amazing about GPT-3, it does some things which no language model could do before. And one of this is this amazing, by the way, if you haven't, oh sorry, we went too far. One of these things is really amazing RAM blog posts. So why GPT-3 is good for comedy, or don't ever do ask me anything on Reddit. So it's really amazing, by the way. It really made me laugh. And I would recommend, if you haven't read it, by the way, if you then when this presentation is over, you can go ahead, get the slides, and in the slides you'll find all the links. So don't worry about the links, everything is in the slides, so you can just get the slides and follow the links there. So this comedy, it's quite long, so I haven't added it here, but it shows that maybe us humans are like really predictable, and our sense of humor is like really dumb. Or it shows that at least GPT-3 is smart enough to understand some things about comedy and understand some things that can make us laugh. So it's of course it's selective. And what Eliezer says, it's best of several. It's not just, you know, random sampled generated text. But if Eliezer says it's scary, I mean, the dude is like the main person, or I guess one of the key peoples in like philosophical AI. I mean, if he's amazed at that, it's pretty impressive to me as well. So all in all, I think we can talk a little bit about what is GPT-3, the key facts, that it's a language model, it's a semi-supervised learning model, it has transformers in it. By the way, I found that not a lot of people are aware of that GPT-3 is really not different at all. I mean, from the architectural part, from GPT-2, it just has many more parameters, or I guess many times more parameters. If I remember correctly, it's about 100 times more parameters. So it's just much bigger model. But in actuality, it's just predicting the next word in a sentence, or I guess in a word list. You give five initial words, and you're asking the GPT-3 model to just predict the next one. It has this few-shot learning like type of working, but it also supports one-shot and zero-shot, and finally it's developed by OpenAI. So by the way, what does this few-shot mean? So if you consider zero-shot, that means you're giving no examples to the model. one shot, you're giving it, by the way, what do you mean by giving it? So GPT, how GPT-3 works, it's just a single model for all tasks. That means you're giving it as an input the task description, some examples, so 0 examples, 1 example, or a few examples, and the prompt. So let's say you have, I don't know, some question text summarization. So with 0 shot case, you are giving it the task text summarize this text. You are giving it 0 examples, and then you're giving it a text to summarize. If it's a one-shot learning, so that means you give it again text to summarize, 1 full text, 1 like long article, and 1 summary. And finally, you're giving it a prompt, which is again a full article, and you're expecting a summarized article. And few shot is pretty much just instead of 1 example, you're giving it this 10 to the power of 1. So about 10 examples, it kind of reaches the plateau and increases just very slowly as it gets more examples. What's really, by the way, you're also seeing this line, like dashed line, if you're giving it no prompt versus giving it a natural language prompt. So natural language prompt is exactly what I said, is you're just giving it a task, summarize this text. And you can see that it's quite a large improvement, right? So if you're just telling it the task, it gives a huge accuracy bonus in addition to that, and things get noisier about with more examples. So like in summary, GPT-3 is really amazing. It showed us, I mean, this was supposed to be the biggest thing in AI in, I don't know, many years, and it was the biggest thing in AI for many years. What I expect to see, one trend which I expect to see in the 2021 is the evolution and application of these big universal language models. So language models which accept prompts as natural language, which can support like 0 shot, 1 shot, few shot learning. GPT-3, by the way, is not the best at every NLP task. It's pretty good at everything, but specialized models most of the time still beat it, but they are very narrow. They can only do 1 task. And what's amazing about GPT-3 is that you just define the task in your own words and maybe give it a few examples for it to work better. So what I really expect to see next year is new applications, maybe directly using GPT-3, maybe using like maybe not a proprietary version of GPT-3, but something like adapted GPT-3 and trained on their own data, or I guess not on their own data, but maybe for their own concrete applications. So these large language models solving real life problems. And I don't expect GPT-3 to be, the final model. It would be super silly to expect that, because it's already the 3rd one. So I'm expecting to see GPT-4 maybe not necessarily next year, but maybe next year. But it's definitely coming, and it's probably going to be even more amazing. I mentioned that GPT-3 was the biggest thing for a while in the AI community, in the AI field, but very recently something really comparatively large was introduced, and this new really amazing thing is called AlphaFold. Or more specifically AlphaFold 2. So it is developed by DeepMind, and one of the very important polls right here is Callum Chase is asking, do you think that AlphaFold is going to be as significant as like Lisa Doe's defeat by AlphaGo in 2016. And most of the people are claiming, like, oh, actually over 90% of the voters are saying yes. So only very, very like small minority saying no, but it's huge anyway, or much less important. Oh, sorry about that. Yeah, so the reason why it is so impressive is that this is the competition to solve this protein folding problem. By the way, the protein folding problem was around for like more than 50 years. It's a really, really hard challenge. It has, like, again, we always brag that, oh, this thing has so many permutations, it's like combinatorially impossible to do anything. But there is even this Levinthal's paradox, which says that this like protein folding problem is so complex that it's like so unlikely that we fold in just a few like milliseconds, or even in some cases microseconds. So it's happening really, really fast. And the problem is pretty much you're getting an array or a vector of proteins, so just a string of proteins or protoproteins, and then we are folding into this 3D structure. So they get this 3D shape. So estimating this 3D shape, what you're going to get when you have this like string of proteins, it's a really hard task. So it took us like previously to correctly do that. I think it took for each protein chain, it was about like something about like $1 million, and it took a bit less than a year, if I remember correctly. And now like AlphaFold can do that like not instantly, but really, really fast. It takes still, I mean, the model is so huge that it takes a while to run the model, and it costs some money to use that many GPUs to run it. But at the end of the day, it's like orders of magnitude cheaper. And this is the comparison from the competition. The higher, the better. So you can see AlphaFold right here on the left, and the next, you know, the next guys are like more than double. The score is like less than half of that. So you can see this quantitative huge, or I guess even qualitative leap forward. It's really amazing that what AlphaFold did. Some facts about it. So first of all, solves the protein folding problem, and I really mispronounced the Levinthal's paradox. So the Levinthal's paradox is about that how can it be that the proteins or polypeptides, I think, the chain of polypeptides becoming a protein. So how can they become proteins so fast? It takes there are so many degrees of freedom, but they seem to do that almost instantaneously. And it's in the CASP competition, we beat the second best thing by such a wide margin. What's really interesting, that the AlphaFold 2, by the way, there was an AlphaFold 1, it was just not a very big deal. It was a pretty good model, but not as amazing as the previous ones, as the second one. And what's really interesting, that the second version is using transformers instead of convolutional neural networks. So it seems that transformers are, again, something to blame, not only in GPT-3, but also in this AlphaFold, enabling using the attention mechanism to, like, in part, by the way, it's not only a transformer, it's a pretty complex model. So like with many parts, so transformers are just a part of that, but it's really interesting that they replaced the CNNs there. let's move forward to the applications of AlphaFold. So like a few things identified by the experts are creating biomaterials. So anything from, you know, like any materials for construction, clothing, or whatever, to like, yeah, pretty much you can do whatever you think with these biomaterials. I mean, with AlphaFold, in the long run, you can create applications for creating biomaterials. You can do next generation supplements for like cognitive enhancements, longevity. You can even like create proteins for treating diseases caused by misfolded proteins. So sometimes the proteins misfold, and that's a pretty bad thing. So now that we can pretty much understand what's happening, then we fold some string of proteins, so we can try to treat it with this better understanding. And finally, you can just use it for agriculture or like decorative plants by enhancing them and having desirable traits. So one of the things which I heard mentioned was adding cold resistance to the crops so that they would not perish if the weather is bad. The trend number 2, which I'm like hoping and expecting to see next year, is the research labs such as DeepMind and OpenAI. They will be making real world impact, or I guess making an impact of real world problems. So like as we can see, like previously, companies such as DeepMind, they mostly focused on, you know, chess, or OpenAI case playing computer games, OpenAI 5. It was never really like having any impact on the real world. And now with GPT-3 and with AlphaFold, we can see that they are focusing on using these really advanced techniques, but for real world problems. I mean, it's like not maybe directly to just solve the real life problems, but it can be used to solve real life problems. It's one of the applications. You have this amazing new hammer, and you have to like pretty much think of what nails you can hammer with this new hammer, but it's a real tool, and it can be used to solve real problems. One thing which both of these things have in common is this, and I hope that you know what this is. So this is the transformer architecture. One of the key things here is the attention mechanism. Transformers were first introduced by Google in their paper "Attention is All We Need," like transformers are like pretty much the go-to things in natural language processing. But as you can see, they are increasingly being used in more and more domains. So one of the really recent things, and this is yet again quite amazing to be in the AI field, because you can do a full presentation with just things that happened in the last 30 days, and like, I mean, the summary of the whole year has 2 of the things which happened in the last 30 days. So one of the really cool things is the vision transformer. It's once again by Google, and the vision transformer is it reaches state-of-the-art results on ImageNet and on 4 other computer vision problems. And as you hopefully know, computer vision was dominated by convolutional neural networks. Computer vision tasks were like, and we had some time. We had like 5 or 6 years, maybe more like 6. We have like 6 years to really perfect the convolutional neural network architecture, from the AlexNet, which was groundbreaking, but a joke compared to the super large and super deep convolutional neural networks of today. It's really amazing that the transformers, they can not only reach comparative results, that they can reach state-of-the-art results. That's really amazing. And by the way, this is not like they haven't won the competition. It's not that they have won the competition. Is what we did. We have this like visual transformer. They took the data sets. They measured what we get on these data sets, and they compare it to the previously state-of-the-art. So as you can see, they reach the state-of-the-art on these six tasks. So that's pretty impressive, and I guess that shows that transformers are getting better. Not only they can be used not only on natural language processing, but also in computer vision. I only wish that somebody would figure out how to use transformers for tabular data, because we have lots of tabular data, and I guess you can only use XGBoost for so many times until it gets boring. So maybe we should use transformers for tabular data. And what do you know? Google have used transformers for tabular data. They have done that about a year ago. And maybe a lot of deep learning people are claiming superiority over the gradient boosted trees. That has been the case for maybe the last 3 years. But if you look at Kaggle competitions, it's really not the case. So even though we have some papers which claim that this is super powerful, but it hasn't been used in Kaggle competitions. However, this TabNet is changing things, and it's starting to being used in these ensembles in the winning competitions. So it's kind of already a proven technology, which again uses transformers for another type of problem, for tabular data problems. So one more usage of the transformers. What's maybe a short summary? So what's really cool is that Google actually uses BERT models for almost all English queries. And it was extremely amazing when I learned that. It was super amazing that Google is insanely huge, and there are so many queries per second, and BERT is a large model. I mean, deploying BERT is a challenge. So they have managed to use that for almost all of their English queries. That's extremely amazing. In addition to that, Huggingface already has 32 pre-trained language models for more than 100 languages. TabNet uses transformer architecture. I don't remember if it reaches state-of-the-art results, but the paper is pretty readable. I think they tell on what type of data sets they're beating gradient boosted trees, and how they compare, how they do feature engineering, how they do pre-processing, how they do feature importance. So TabNet paper is a good read in general. But in addition to that, you learn about the difference between the performance of gradient boosted tree type of models and this TabNet. Finally, this new vision transformer is state-of-the-art on ImageNet and 5 other tasks. So I guess the trend is pretty clear. We are going to see the usage of transformers for most of machine learning problems. And what we don't have yet, at least what I don't know yet, is usage of transformers for like sequence models or time series models, time series problems. We haven't seen that for maybe more complex type of not image information, but for video information. Like I expect to see maybe a wider adoption of transformers, because right now we are just in the first stages of using transformers for NLP tasks. We are pretty much in the very first stages in using that for tabular data and the vision transformer. I mean, nobody's using transformers for computer vision tasks. So I expect to see that next year. Hopefully this vision transformer is a real deal, and it can increase our performance on computer vision tasks where maybe we are stuck, or maybe we can just do an ensemble of CNN and this visual transformer. Trend number 4 is I'm going to expect to get more data, or for the deep learning and machine learning practitioners to be able to use more data by keeping it private. By the way, what do I mean by keeping it private? There are lots of data sets which are protected for some reason. It might have sensitive data. It might have like user settings not to send any data to the cloud provider. It can like be a million things, but what's really amazing is that companies are like really investing in the security and privacy of deep learning. One of these like approaches is training with using encrypted data. So they're actually maybe not necessarily training using encrypted data. It can be, maybe there should be a star there, because for example, federated learning is a bit of a different approach. It isn't really training, it's just it's training on private data, not on encrypted data, and then just sending the models to be combined then later in the cloud. So it's still like the pre-trained model is encrypted data in itself, but it's not really only data. So there are 3 main approaches: federated learning, differential privacy, and encrypted communication. And some major tools, Opacus and Krypton from Facebook, and PySift from OpenMinded. In my mind, the biggest one is the OpenMinded. It supports all of the 3 approaches. It's more, you know, Facebook can be a little bit controversial as a company, but I mean, OpenMinded is more I guess like more open. They are all open source, by the way, but you can expect it to work with more frameworks. You can expect it to be for the wider community than the Facebook libraries. And it's like, at least in my initial overview, it looked quite well documented. I haven't used these tools myself, but I'm really looking forward to see more data sets being actually freed for training, for being trained on, and I expect the libraries to help with that as well. And the trend number 5 is very related to the libraries. It's the new tools. So for a while in deep learning, we had like these 2 main tools, so PyTorch and TensorFlow. It was like these 2 tools were dominating the industry for, I don't know, maybe like 3 or 4, yeah, about 3 years. And like recently we've seen a newcomer, JAX from DeepMind. It's pretty amazing. By the way, it looked really similar to PyTorch for me, and I guess Google is like my initial reaction is okay, so Google is building their own PyTorch. Why are they doing that? But I guess I haven't used JAX, like, I mean, for anything, but like the initial investigation like looks really promising. I see increasingly, even, you know, like libraries such as Huggingface transformers, They are starting to support JAX. They have like a separate column for what's supported in TensorFlow, what's supported in PyTorch, and what's supported in JAX. So this new thing might give TensorFlow and PyTorch a run for its money, especially if it can inherit the TensorFlow ecosystem, which is amazing. And with the actual productivity and usability of PyTorch, it can be really, really amazing combination. So the best of both worlds. And talking about, like tools, we have a lot of new tools for productionizing machine learning models. I guess what I really noticed this year is the super significant growth of companies which provide machine learning ops as a service. That means they can productionize your model for you. You can just like drag and drop the model, and they'll take care of everything else, like deploying the model, scaling the model if it gets more traffic, logging the model metrics, etc., etc. So the tools which I really want to point out are Kubeflow. Kubeflow is a pipeline manager. It actually has maybe not only that, but Kubeflow is like a toolbox of machine learning tools. One of the major ones of it is Kubeflow Pipelines, which is a pipeline organizer which just runs like whatever you want step by step. And we actually use Kubeflow at work. It's a pretty powerful technology which allows us to build to deploy our deep learning models with in a much more robust way, in a much more monitorable way, in a much more reproducible way. So it's really powerful and maybe a little bit cumbersome, but yeah, it's still amazing. Then we have Onyx, so the for maybe translator from one format to another. And I hear a lot of companies increasingly use Onyx for before deployment. It has like some performance benefits. It can if you have like a TensorFlow system and somebody makes a PyTorch model, you can just translate it with Onyx and go ahead and deploy it. The other tools are DVC, so that's data version control. MLflow does a lot of metric tracking. Polyaxon, it's like, again, all of these tools are constantly evolving and doing more and more, but Polyaxon is quite similar to MLflow, but I think the deployment is an extra step. And Seldon is pretty much all for deploying the final step of the pipeline, just deploying the models themselves. So they are all very powerful tools for productionizing machine learning models. We are all very new. We are all, like, I would say, not like production tested yet, but we really didn't have time to use a lot of models in production. And they're getting more robust with pretty much some tools which we haven't used like half a year ago because they were just too new. Seems to be adding a lot of community and a lot of actual use cases and documentation, and they are becoming more and more robust, more and more production ready. Finally, one of the really cool things which I have read about quite recently by DeepMind is that they are using Unity for creating learning environments. Never knew that, and that seems pretty amazing. So we are using that for their reinforcement learning models to train in better simulated environments. So pretty impressive usage, or I guess lateral thinking from the DeepMind point of view. That we are like, I mean, Unity is doing quite a bit in the AI and like adopting this as a standard seems to be pretty powerful from the DeepMind's point of view. Finally, just with a disclaimer that it's not going to happen in 2021, but Python is like right now, I mean, unbeatable in the deep learning, field. It's the language which everybody has to know. If you want to do anything with deep learning, you have to use Python. I mean, there are exceptions, and I know that you might have used like R or Java or Scala, but let's be honest, it's all about Python now. Python is an amazing language, but that said, it has some drawbacks. And like I increasingly see people in the community looking for alternatives. Some maybe like the 5 notable alternatives which I have seen some investment, like, or I guess in some more investment, in others like a little bit less, but all of these 5 languages, in my opinion, can be the ones which will take the mantle sometime. Again, not in 2021, but sometime they might take the mantle of the king from Python, because we probably need a bit more, like if you want to see these machine learning models like more productionized, used in really critical like systems, Python like either has to step up their game in some regards, or we have to get a new language as an alternative. So one of the things is, one of these languages is Go, popular language by Google. Then we have Swift, and what's really impressive is that Swift already has, already had this TensorFlow port. So Swift for TF, then Julia, the data science language. From the people which have used Julia, I heard only amazing things. So haven't used it myself, just read a bit of code. Looks pretty good. Then Rust, one of the favorite languages of all time for everybody, who uses Rust seems to be really in love with it. And Kotlin, the Android language, but again it has some already work done for deep learning. So maybe the language which will replace Python is not in the list. Maybe Python will remain the king for like 10 more years. I find that not very likely, but we are going to see some competition, in my opinion, in the near future. And I would like to end today's presentation with this quote from Andrew Yang. So it is difficult to think of a major industry that AI will not transform. This includes healthcare, education, transportation, retail, communications, and agriculture. There are surprisingly clear paths for AI to make a big difference in all of these industries. So my meta trend, which I am increasingly seeing, which kind of makes all of these other trends like a sub-trends of that, is the real application of deep learning technologies or AI technologies for solving real-life problems. When you think about it, all of my today's examples, all of them are like a subset or a means to an end, how to use this amazing new thing, which is deep learning, to really make an impact in these large industries which have to be disrupted. So that's all the presentation which I have today. Let me switch to your questions. And yeah, give me a minute. I see a question. I don't see any questions so far on the Google slide. So if you have any question, go ahead, ask it now. I see Andrews asks, would be nice to have all the links in the description. I think I can do that. I think I'll get all the links and I'll paste it on wherever you find. We have like a few places where we are posting the meetups. So I'm going to paste it on Tribe of AI because every single other one has a link to Tribe of AI. So on Tribe of AI, I'm going to update the event, I'm going to add the slides, I'm going to add the recording, and I'm going to add all the links. So you'll find the links there. Oh, everybody's really shy today. No questions yet. And I mean, we can continue the discussion offline then. So if you have more questions, just post it on in the thread below the event, and we can chat for a while there. So thank you all for being here. Remember, we have like so many amazing things coming, like the new Tribe of AI Academy teams looking for mentors, also the Artificial Intelligence of Lithuania, this new members page, and finally, maybe you're interested in becoming a member of our association. So all of these things are going to be posted, and I'm super happy that we are seeing so many new developments both in the world and in the artificial intelligence in Lithuania. So thank you all for being here. See you next time. Bye bye.